Hello friends, in this tutorial we will talk about streaming data collection using Kinesis data streams, Kinesis Firehose, Kinesis video stream and Kinesis data analytics. If you have not seen the previous video on data collection, then please do watch it. It will give you the basic understanding of data collection. You can find the link in the description. So let's start the tutorial without wasting any time. In this chapter, we will talk about streaming data collection. Now, if you are following along with our machine learning cycle, we are still talking about ways to fetch our data so it's ready for our machine learning process. We will talk about ways to stream our data into AWS. So, when you are ready, join me. Let's go ahead and discuss some streaming data collection concepts. But before we go any further, I would like to talk about some of the earliest data collection that we know of. Now, some of the earliest data collection can date back to as early as 2000 BC, where Egypt collected census data about the people who lived there. Now, the reason that they gathered this data was to tax purposes and to determine fitness level of military services. Now, capturing this data was important because they needed to understand and determine different information about the people. And at the core of it, data collection is the same today. We use the data that we collect to understand current information and determine predictions for future events. So we know that data comes from a lot of different places, and majority of the time we can capture our data as static data or streaming data. We can think about static data as data that's not changing, or data that we download and then do something with. Most of the in-house datasets that your organization has collected and stored in a data warehouse or a data lake is considered static data. This data has been collected over many months or many years, and it's your job as a machine learning specialist to do something with that data. Now, streaming data is a bit different because streaming data is constantly being updated or continuously being added onto during the data collection process. Now, depending on your machine learning project, you may already have loads of in-house data that you are able to work with. But if not, there are several different places that we can get public data to analyze and use within our machine learning projects. And the first place that we will talk about is a website called Kaggle. Now, Kaggle is an online platform that allows you to search through different types of datasets and interact with others who are doing machine learning or analyzing different datasets. They also offer different competitions and provide you with datasets to help analyze and solve different problems. The dataset that you can find here are free to download and come in many different formats. So if you get a chance, check out kaggle.com. Another place to find open source datasets is from the University of California Irvine websites or UCI. This website and repository has many open source and great example datasets that many people use during machine learning projects. And during machine learning example, there is also an open data on AWS, which is an open source comprehensive toolkit for sharing and analyzing data at any scale. What AWS allows organizations is upload their datasets onto AWS and make them public. So anyone can view them and access them and use them for analytic services. And another place to find open source dataset is through Google's BigQuery. Google's BigQuery allows you to run queries on different datasets and return the data in whatever format you would like. Now, these are just a few different resources that you can use to capture static data or download data for your machine learning projects. Now, if you have the data, it's simple. You just load into AWS, and there is a few different ways you can do this. You can simply do it through the console via S3, or you can do it using one of the AWS many SDKs with code like Java or Node.js or C# or you can upload your data via command line using the AWS CLI or the AWS command line interface. Getting static data into AWS is so easy. You just simply upload it and it's ready to go. You are ready to use it within your machine learning project. But the next question is, well, what about streaming data? Some examples of streaming data might be sensors in the transportation vehicles or industrial equipment and farm machinery that sends data to streaming applications. Think about financial institutes that tracks data for the stock market prices in real time and computes value at risk and automatically rebalances portfolios for stock price movements. What about real estate websites that tracks the customer on mobile devices and make real-time property recommendations of those properties depending on where they are in the world or what their geolocation is? And what about the websites that need to stream clickstream data for recommendation or give their user the best experience? And what about the online gaming companies that collect streaming data about gameplay or interaction and feeds that data back into the gaming platform? These are just some examples of streaming data, and the ways that can be handled streaming data are either through some streaming processes or we can process them in batches. Now, we will talk about this over the next few chapters, but start thinking about, well, how do we get our streaming data into AWS? Well, luckily, there is a tool or a family of tools that we can use to stream our data into AWS. We can also use these services to stream our data into our machine learning process and create real-time prediction. And the services that we use to do this is Kinesis. Now, the way that I like to think about Kinesis is not necessarily one tool, but a family of tools. So, I would like to introduce you to the Marvel family. Now, the Marvel family or the Shazam family was a family of superheroes created in 1942, which included the characters Captain Marvel or Shazam, Mary Marvel, Captain Marvel Jr. and Uncle Marvel. And you can see the Marvel family here on the cover of this comic book, where the mighty Marvel family joins forces versus Black Adam. Now, the reason that I like to compare the Shazam family to the Kinesis family is because Kinesis consists of several different services that make up the entire streaming family. Now, the Kinesis family consists of 4 different services, and these services are Kinesis Data Streams, Kinesis Data Firehouse, Kinesis Video Streams, and Kinesis Data Analytics. Now, over the next few lectures, we will go over each one of these services in depth and talk about how we can use one or more of these services to stream our data into AWS. We will talk about how we can implement different applications to handle different type of streaming data. So it's ready for our machine learning process. That's it for this lecture. If you have any questions, please try to post it in the comment section and I'll try to answer it. So let's move to the next lecture. So the first part of Kinesis that I like to discuss is Kinesis data streams. Within the Kinesis family, there are several different services that AWS offers for us to use to handle our data streaming. Now, we will go over each one of the services over the next few lectures, but let's start with Kinesis data streams. Now, the way that Kinesis data stream works is by getting data from data producers, and these data producers typically have some type of JSON data as the payload, or they can use any type of data that they can fit into a data blob. And the data producers are different devices or applications that produce streaming data. For instance, data producers can be things like application log files or social media streams. They can be things like real-time user interaction from video games. They can be IoT devices or manufacturing devices in a factory. They can also be a clickstream data or user interaction For an online website or application, data producers are the physical devices that produce the data that we want to get into AWS. Now, once the data is produced, we can then use Kinesis streams to transfer or load or stream that data into AWS. And the way that Kinesis streams carries that data is by using these things called shards. Now, the way that I like to think about shards is a container that holds the data that we want to send into AWS. Now, shards are made up of a couple of different parts that we will discuss over the next few slides. Once the data is contained within a shard, then we use data consumers to process that data or analyze that data. Now, data consumers can be things like EC2 instances, or it can be Lambda functions where we can do real-time ETL processes. We can also use another tool within the Kinesis family called Kinesis Data Analytics to run real-time SQL queries on our streaming data. Or we can send our streaming data to an EMR cluster and process it using Apache Spark. And what's great about Kinesis data streams is what we can have multiple consumers consume this data stream or consume those shards and perform different processes depending on the job at hand. Now, depending on what you want to do with your streaming data, you can use any of these consumers to process the data or further analyze the data or send it to off a data store within AWS like S3, DynamoDB or Redshift or other business intelligence tools. So just remember that when using Kinesis data streams, if we wanted to store off our streaming data into, let's say, S3, we would have not used some intermediate services like AWS Lambda to take the input, streaming data and output into S3. Now, in the next lecture, we will talk about a service that's made specially for outputting streaming data onto one of the AWS data stores. But for now, let's go ahead and talk more in depth about what shards are, because this is an important part of Kinesis data streams. So as I mentioned earlier, shards are the wrapper or the container that contains all of the streaming data that we want to load into AWS. And a shard is made up of a couple of different parts. Now, there is a unique partition key for each shard. So if you look at this example, we have two shards and the partition key for shard 1 is unique, and then partition key for shard 2 is different and it's unique as well. Now, each time that we make a request to send streaming data through Kinesis stream, it creates a sequence, or as we depicted here, one of these little red boxes, each payload that we make creates a sequence which is associated with a shard. Now, the more requests we make and the larger our payload gets will determine how many shards we use. Now, the number of shards that you can use is from 1 to 500 by default, but you can request more shard if needed. So another way that I like to break down what a shard looks like or is made of is by looking at this example. Let's say we have a couple of different railroad track lined up together. Now the train ID is going to be the partition key. So the first train up top is going to have a unique partition key, and the train on bottom is going to have a unique partition key as well. Now each cart on the train is considered the sequence number. So if it has cart 1, cart 2, cart 3, that would be the sequence number associated with the shard, and the actual passengers that are within the train is considered the data. So this is just a quick little example of how I like to imagine shards and Kinesis data streams. Now we have talked about what shards are made of or what consists within a shard. So let's take a look at what AWS offers for shard. Now each shard consists of a sequence of data records. You can think about those little red boxes. They can be ingested at 1000 records per second. Now we already mentioned that the default limit of shard is 500, but we can request increase to unlimited shards. And we saw how those little red boxes or a train cart is a data record, which is the unit of data that's actually captured. And this consists of the three parts, right? A sequence number or the train cart, a partition key or the ID for the train, and the data blob or the people within the train. And our data blob can be up to 1 megabyte in size. Now, an important feature about shards is that they are a transient data store, meaning that the data is held within a shard, or the data records by default for 24 hours, but we can increase that up to 7 days. So for example, if some type of failure happens or your consumer application fails, the data within that stream is going to be held on to by default for 24 hours, but we can increase that up to 7 days. So it's essentially like a mini brain that remembers the information or holds onto the information if needed. So the next question is, well, how do we actually load our data? Or how do we actually get our data into a shard? Or how do we get our data into Kinesis data streams? Well, there is a few different ways to interact with Kinesis data streams, and we'll talk about those now. The first way that we can interact with Kinesis data streams is by using a product called Kinesis Producer Library, or abbreviated as KPL. And this is an easy to use library that allows you to write to Kinesis data streams. What it does is it allows you to use some of the robust feature and mechanisms of Kinesis that you would normally have to write by hand if you were just using the Kinesis API. Things like retry mechanism if for some reason the stream did not get processed, things like optimizing throughout and aggregating records together so you have the most optimal stream. So what you can do is install the Kinesis Producer Library onto two EC2 instances or integrate it directly into your Java application. Now, once the data is in Kinesis data streams, you can use Kinesis Client Library, or abbreviated as KCL, to directly interact with the Kinesis Producer Library to consume and process data from Kinesis data stream. Both of these libraries are used to abstract some of the low-level commands that you would have to use with the Kinesis API. So the last way I want to talk about interacting with Kinesis data streams is by using the Kinesis API. Now, with the Kinesis API, we can perform all of the same actions that we can perform with the Kinesis Producer Library or the Kinesis Client Library, but it's used for more of low-level API operations and more manual configurations. So let's go ahead and take a look at some key features between the Kinesis Producer Library and the Kinesis API. With the Kinesis Producer Library, we said that it provides a layer of abstraction especially for ingesting data. Now, we can perform the same actions with the Kinesis API, but things like automatic retry and the aggregation of records for optimization is done automatically with the Kinesis Producer Library. And we have to do it manually with the Kinesis API. With the Kinesis API, things like stream recreation, resharding, putting and getting records are manually handled. Now, one thing to remember about the Kinesis Producer Library is that sometimes additional processing needs to be done. So things like higher packaging efficiencies and performance can be taken care of. Now, with the Kinesis API, there is no delay in the processing, but you may not be packaging and optimizing the Kinesis data streams properly. It really just depends on how you make the API calls. So, depending on your use case, if you need your data stream immediately available within milliseconds, it may be better to use the Kinesis API because of the additional processing that could delay your streaming data with the Kinesis producer library. And finally, the Kinesis producer library is used as a Java wrapper, so you would have to implement it using Java. While the Kinesis API, you can use any of the supported AWS SDKs, things like C# or JavaScript. So just remember these features when deciding whether to use the Kinesis producer library or the Kinesis API. Now, within the console, it's pretty easy to create a Kinesis stream. Essentially, you just provide a Kinesis stream name and then the number of shards that you want to use. Now, luckily, there is a little tool that you can use within the console that allows you to estimate the number of shards that you really need depending on your payload size and the number of requests. Now, you can always reshard, which enables you to increase or decrease the number of shards in a stream. And this is to adapt for any changes in the rate of data flowing through the stream. Now, resharding is typically done by a separate application that monitors the metrics from the producers and consumers and makes an API call to add more shards if needed. Now, the documentation states that resharding is considered an advanced option, but you have to have an option to reshard or add or decrease the number of shards after you create a stream by using the Kinesis API. So let's answer the question. Well, when should you use Kinesis data streams? Well, when you need the data to be processed by consumers, meaning that you are not looking to immediately drop your data into a data store, but rather you would like some transformation done, or you would like to some analytics ran on it, or you want to feed that data into another AWS services. And just remember that with Kinesis data streams, storing the data is optional. You might just want to consume that data and run some analytics on it or feed it into another service, but never store the data. And finally, the last thing that's important with Kinesis data streams is that it provides data retention. This means that if a data is super important and you can't afford to lose that data, data retention is built into Kinesis data streams and allows you to hold on to that data for 24 hours or up to 7 days. This is built in just in case there is some failure within your application or your infrastructure and you need to reprocess the data that's within the stream. And finally, let's take a look at some use case where we could use data streams or where it would be good to use the data streams. If we wanted to process and evaluate log files immediately, we could use Kinesis data streams. So for example, if we had an application running and we needed to process and evaluate the log files that the application produces, we are able to analyze and continuously process that data within seconds. We could run analytics on the log files. We could do some type of transformations, and we could also store the data off into another data source like S3. Another example is if we wanted to run real-time clickstream data analytics. So for example, if we had an e-commerce site and we wanted to know what a user was clicking on and what products they liked, we could use Kinesis data streams to stream that information and analyze that data and offer them real-time suggestions on other products that they might like. So I hope this gives you a good understanding of what Kinesis data stream is, what shards are, and how we can use Kinesis data streams throughout our machine learning process. So that's it for this lecture. If you have any questions, then please post it in the comment section and I'll try to answer it. In this lecture, we are going to discuss Kinesis Data Firehose. We are still talking about the different services within the Kinesis family, and we have already discussed what Kinesis data stream. In this lecture, we will talk about Kinesis Data Firehose. Similar to Kinesis data stream, we get our data from data producers, and these can be things like application log files from EC2 instances or servers, or real-time clickstream data from an e-commerce website. It could be things like IoT devices or sensors on manufacturing devices. Any type of streaming data can be considered a data producer. Now, with Kinesis Data Firehouse, we no longer have to worry about shards. And since we no longer have to worry about shards, we can pre-process the data using AWS Lambda, which acts like a ETL service right before we land our data on some data store. Now, with Kinesis Data Firehouse, we can land our data onto Redshift, S3, Amazon Elasticsearch, and Splunk. Pre-processing the data with Lambda is optional, so you don't actually have to use Lambda to pre-process the data. You could actually just stream the data directly from Data Firehouse all the way to store. So Firehouse is going to be your delivery service for streaming data. We can also take advantage of S3 events, which allows us to call a Lambda function when any event happened on the S3 bucket. So for example, if we have something streaming data that lands on an S3 bucket, we can create an S3 event that calls a Lambda function that pushes the data onto DynamoDB. So just remember the different places where Kinesis Data Firehouse can output your data onto or deliver your data onto like Redshift, S3, Splunk, and Amazon Elasticsearch. But in the course, we will mainly focus on outputting our data onto S3. So what it does is it allows you to easily stream data to a final data source or a final destination. So just remember the difference between Kinesis data streams and Kinesis Data Firehouse. And the way to do that is remember that Kinesis data streams has shards and has data retention, meaning that if there is some failure in your processing tools, then Kinesis data streams hold on to that data, so you are able to reprocess it. Now with Kinesis Data Firehouse, you don't have to worry about shards, and this is mainly used for streaming data directly into some storage or data repository like S3. And if you remember, with Kinesis data streams, storing the data is optional. We could run some analytics on it and then get rid of the data and never store it. But with Kinesis Data Firehouse, really our end goal is to store off our data somewhere in AWS like S3. So let's answer the question. Well, when should we use Kinesis Data Firehouse? Well, when you want to easily collect streaming data. So if you just want to take streaming data from some service, some IoT device, maybe some clickstream data from a website and store it directly onto S3, then Kinesis Data Firehouse is really easy to use. You just point your data to Kinesis Data Firehouse and set the output destination, and Kinesis Data Firehouse will handle the rest and output your data onto whatever data store that you decide. And remember that processing the data is optional. We can always run the data from Kinesis Data Firehouse into AWS Lambda, run some ETL processes, and transform your data, and then output onto a data source on S3. But processing is optional. We don't have to do that. And like we said, if our final destination is S3, then we might want to use Kinesis Data Firehouse. And finally, if data retention is not as important, meaning that if we lose a few records within the streaming data, it's not the end of the world, and we can just continuously process the data and store it onto the data store. So what are some use cases for Kinesis Data Firehouse? Well, if we wanted to stream and store data directly from devices, what we can do is capture important data from IoT devices or embedded systems or things like customer application and store that into a data lake. Kinesis Data Firehouse is a great way to stream our data from our data input sources and store it onto S3 to create a data lake. And we can also use Kinesis Data Firehouse to create ETL jobs on streaming data. So remember, when we were talking about data stores, we usually do some type of processing before we load our data into a data warehousing solution. So we could always create ETL jobs using AWS Lambda to transform that data before we land it into our data warehousing solution. So these are a few different use cases of Kinesis Data Firehouse. And just remember the difference between Kinesis data stream and Kinesis data Firehose, in the sense that Kinesis data Firehose, you no longer have to worry about shards, and really the end goal is to get our data into some data store like S3. If you have any question, please write it in the comment section and I'll try to answer it. So let's go ahead and move to the next lecture. Now moving right along, we will go ahead and talk about Kinesis video streams. As the name suggests, Kinesis video streams is a service that allows us to stream videos into the AWS cloud. What you can do is build real-time video processing application, and if we wanted to use videos within our machine learning process, we could use Kinesis video streams to stream those live feeds or stream those videos into AWS. And we will also see how we can use Kinesis video streams to stream images in real time or stream audio files in real time. Now, the way the Kinesis video stream works is you have your data producer. Now, these can be webcams or these can be security cameras. These can also be things like non-video data such as audio feeds or images or radar data. And these data producers send the data into AWS, where we have different types of continuous or batch consumers. And these are the applications that are going to consume and process the video streaming data. Now, the way that these consumers get the data is in fragments and frames from a Kinesis video stream to view, process, and analyze it. Generally, these consumers are called Kinesis video streams application. What you can do is write applications that consume and process the video streams in real time, or after that data has been stored onto S3. You could write the application to process it once it's been stored and you know with confidence that it is durably backed up, and we can write our consumer applications on Amazon EC2 instances. Now, once we process or consume that data, we can always store it off to S3, or we can store it off into S3 and then consume that data and process it and analyze it however we can see fit. For instance, for our machine learning models, so let's answer the question, well, when do we need to use Kinesis video streams? Well, when we need to process real-time streaming video data or audio images or things like radar. If we wanted to do batch processing and store streaming video, then we could Kinesis video streams. And finally, we could use Kinesis video streams to stream those videos or images into other AWS services like AWS SageMaker to run some machine learning processes or use that data for testing or training data. The way that I like to think about Kinesis video stream being used in the real world is from a product made by Amazon called Amazon Cloud Cam. Now, I personally have one of these Cloud Cam setup, and what it does is it detects movement or it detects a person within the video stream, and what it will do is send out a text message out of my phone and say, hey, you know, we have detected some movement on your video stream. Now, I know that there are some machine learning setup in here because it's able to detect a person over just movement, and it's also able to detect things like dogs barking. Now, the way that I imagine this setup is AWS streams this data onto some EC2 instances that process it and determine whether it's a person or not. So, it's calling the inference of the machine learning model. If it does detect a person, then it sends a message out to my phone, and you could think about this being done with maybe AWS Lambda or an EC2 instance, and it stores that video off into S3 so I can go back and view that video to see why the camera detected movement or see who the person was. So every time I get a text message from my phone saying, hey, there is a person detected, usually it's just a mailman. I think about all the processes and interworkings that are occurring every time my Amazon Cloud Cam detects movement. So anyways, this is just a simple use case for Kinesis video streams. And if you have any questions about this lecture, then please post it in the comment section and I'll try to answer it. If not, then let's move on to the next lecture. Now, the last service in the Kinesis family that we will talk about is Kinesis Data Analytics. Now, Kinesis Data Analytics is a pretty powerful tool, and what it does is it allows you to continuously read and process streaming data in real time. And we can do this by using SQL queries to process the incoming streaming data and produce some output data from that. So the way the Kinesis data analytics works is it gets its streaming input data from services like Kinesis data streams and Kinesis data Firehose, which we talked about in the last few lectures. We can then run it through Kinesis data analytics, run real-time SQL queries, and output those into S3 or Redshift or other visualization tools or BI tools that you may choose to use. This means that we could run complex SQL queries like transform date times or change data types, possibly change column names. We can do complex joins and do all of this on streaming data in a real time and then stored off into S3 for our machine learning process down the road. This will allow us to do some pre-processing before we do more processing in the end if needed. Now, within the console, Kinesis Data Analytics is pretty easy to set up. You essentially just tell it where the streaming input source is from, either Firehose or data streams, and you are able to write SQL queries and output those results onto S3 or just view them in real time. So the next question is, well, when should we use Kinesis data analytics? Well, when we want to run SQL queries on streaming data, now we can use SQL or we can use Apache Flink. So we could write applications that sit on the top of Kinesis data analytics and provide real-time insights of our data. What we could do is create metrics and dashboards, things like monitoring and notification and different alarms. Whenever certain thresholds are hit or any type of analytics or anything that we want to see within our streaming data, we can use Kinesis data analytics to create these different metrics. And finally, if we want to output the query results and S3 or the AWS data sources, we can use Kinesis data analytics to run real-time queries and output the result into S3. So what are some use cases of Kinesis data analytics? Well, if we wanted to run responsive real-time analytics for our application, we could set up alarms or notifications by writing certain SQL queries that if they hit below or above a certain threshold, we could send out notification to our users or show them on a real-time dashboard what their streaming data looks like. And finally, if we wanted to stream our ETL jobs, we could get raw sensor data and do things like clean, enrich it, and organize it and transform it before it lands into our data warehousing or our data lake solution. So this would be a great way to pre-process our streaming data before it lands onto S3 or any other data store that we would like to use. So now that we have discussed all the different services within the Kinesis family, I would like to give some scenarios and see if we can decide which Kinesis service to use within the Kinesis family. So the first task is we need to stream Apache log files directly from, let's say, 100 EC2 instances and store them into Redshift. Go ahead and take your time and see if you can figure out which Kinesis service to use and pause the video if needed. Alright, are you ready? Since there is no pre-processing that needs to be done on this data, we can use Kinesis Firehose to easily string this data to our final destination. Once the data is loaded into S3, we can then copy it over to Redshift. Next, we need to stream live video coverage of a sporting event to distribute to customers in real time. Now the Kinesis service that we'll use is Kinesis video streams, and this is because we use Kinesis video streams to process real-time streaming video data and audio images and radar things like that, or feed into a custom application or other AWS services. So we can stream this data into AWS Lambda and then store that data into S3 or other data sources, or feed it into custom application or our machine learning process. And finally, the last task is we need to query real-time data, create some graphs and store that output onto S3. Well, this would be a job for Kinesis Analytics. And this is because Kinesis Analytics allows us to run SQL queries on our streaming data and then output the result into S3 or other data stores. So just remember how you can use each one of these for the different types of streaming data. And just remember that Kinesis data streams uses shards and has data retention, while Kinesis Firehose you don't have to worry about shards and there is no data retention. And Kinesis Firehose is mainly used to directly output the streaming data into some data store like S3. So that's it for this lecture. If you have any questions, please write it in the comment section and I'll try to answer it. So let's go ahead and move on to the next lecture. In this chapter, we will summarize all the topics that we have covered in this module, that is streaming data collection. So we first started talking about loading data into AWS and just understand how to get data from public datasets or in-house datasets and load into AWS. Remember that we can load our data into S3 by uploading it through the console. We can use the S3 API or we can use the AWS command line interface to get our data into S3. And remember each of the services within the Kinesis family and how they are used to process and handle streaming data. Be sure you know what a shard is, what a data record is, and the retention period for shards. By default, the data retention is 24 hours, but we can extend that up to 7 days. Make sure you know the difference between the Kinesis producer library, the Kinesis client library, and the Kinesis API. Remember that the Kinesis producer library abstract some of the lower level commands that need to be done with the Kinesis API, but sometimes there might be a delay in the processing of our data if we use the Kinesis producer library over the Kinesis API. And finally, for a given scenario, just know which streaming Kinesis service to use and how each service can fit into your streaming data needs. Now, be sure that you read and watch any of the additional resources that I have provided. So congratulations on finishing this chapter. So if you have any questions, you can post it in the comment section and I'll try to answer it. That's it friends in this lecture. I hope you got theoretical understanding of streaming data collection using Kinesis. In my upcoming video, I will give you a demo on AWS console and show how to perform data collection using Kinesis. If you like the content, then do like it, share it and subscribe it. Thank you.